Welcome to the session on engineering graphics. In today's session, we are going to see the reconstruction of second stage top view to the third stage top view with axis inclination. So in this problem, the true length of the axis is 60, apparent length of the axis is 45.96 and the true inclination of the axis is 30. So true length will have true inclination, apparent length will have apparent inclination. So we know the true inclination here, okay, so which is given 30 with VP and the axis length is 60. So to get that one, what we do, we get one line parallel to XY. So I am taking this line parallel to XY because when we are drawing this figure over here, it should not cross the XY line. So line parallel to XY, I am taking it approximately 30-35 mm distance. Then from there, I am getting one line which is having a true length, that is 60 mm, and angle is 30 degrees. Okay, so this is the line what I have drawn, which is having a length of 60 and the angle between this horizontal line is 30. So true inclination and true length I have drawn. Then this point will give us locus of the other point, that is O1. So I have got the locus here. Okay, so I will be naming the points here. This is O and this is O1. So for the second stage, we have got the O1 in shortened length or the apparent length. So that shortened length we know it, that is 45.96. So from this point we will be having 45.96 and will be cutting the arc here. Okay, so after that I will be connecting this O point to this. Okay, so I will be getting this as axis of the second stage. So I will be naming this point as O1. So now with respect to this O1, we have to reconstruct this figure over here. So one thing is that this O1 is parallel to AA1, BB1, CC1, EE1 and DD1. So if O1 is 45.96, remaining AA1, BB1 to EE1, all 5 lateral edges will be having the same length. So keeping that in mind, first we will reconstruct only this pentagon and remaining points we can mark from these points at a distance of 45.96. So first we'll have this pentagon and we'll enclose that pentagon in some rectangle. Say from this point, okay, so from this point till this point, okay, we are enclosing it as a rectangle. So now when we have got this rectangle, we have got all the some of the points of this pentagon on these lines. Okay, so see, if this is a rectangle which we have drawn, so A1, B1, C1, D1 and E1, all 5 points are on this rectangle. Now to get this rectangle, we have to get the distances from O1. Say from O1, if we have got some distance from O1 till here to here, it is 11.6. and here to here it is 13.67. So again we will go to this O1 point. So from there we will be getting 11.06. okay, and then from here, okay, so I'll just increase the thickness here. Then from this point it is 13.67 on this line. Okay, so now I have got the two what we say, the lines. Okay, so from here, okay, so again I'll take it 13.67, enter, and this line I want it, this line I want parallel with this one. Okay, parallelism this line with this one. Okay, so this line I have got it. So now from this line I have to get the rectangle. So now I'll get the rectangle from here. Okay, so like this. So this line you can make it 90 degrees to this. So similarly from the other point, from here just get a line and make this line 90 degrees to this, like this. Now from here we have what the distance of A1 B1 and C1 E1 as well as the D point. D point you have got it here. Now we have to get the AA1. Okay, so now to get the AA1 we have to measure the distance from here till here, that is 12.5, and if I measure it here on this side, that is 12.5. So same arc you can take it from here. You can get the arc of radius 12.5, enter it. You can cut it on this side. Similarly, you can take the arc from this point and 12.5 you can get it on this side. Okay, so now A1, B1 you have what, D1 you have what, remaining are E1. So to get E1 and C1, so again I will be measuring the distance, say from this point. Okay, from this point we can measure the distance of, or you can go to the directly distance between this line and this line. Okay, so that is 20.23, distance between this line and this line, that is 20.23. So similarly you can have one line from here, or you can take the arc on both the sides from here, 20.23, enter, get the radius here, and from this point again 20.23, get the radius here. So now if I zoom only this portion, you are getting A1, B1, C1, okay, and you are getting the points which are, sorry, this is not C1, you are getting the line for the rectangle. So if you trim these lines, okay, if you trim these lines and if you draw one line from here, okay, so like this, you have got the line. So I just showing it manually, you can do it very easily. So just get this line perpendicular to this line perpendicular to this. So now you have created the rectangle which you wanted. So now I'll trim the remaining extra lines which we don't want. Okay, so this is the rectangle what you want, that you have created. So you have what, A1 here, okay, so you have what, B1 here, then you have what, D1 here, and you have what, O1. So now remaining E1 and C1. So to get E1 and C1, so again we can measure the distance of E1 and C1. Already we have measured it, that is 20.23 from this axis, but on this line we have to measure it. So from this point to this point, okay, so 15.28 I am getting, and from this point again if I measure it, okay, so till here 15.28. So I can get the same thing here, get the arc from this point, that is 15.28, you cut it here. Okay, so on one side if you cut it, you can draw the line to get the other point. Okay, so if you are getting this as E1, you get one line from this which will be parallel to this line, parallel to this. Okay, so parallel, again you can have the line parallel to this using the scale. Okay, so very simple, it is using the scale you can get it. Now you have what, the points which is C1, okay, and here you have what, E1. So you have what, all the 6 points of one rectangle. Now for further what you have to do, you have to get the distance of 45.96 there, and you have to get the lines from this point parallel to this O1. So that will show you here. Okay, so you have got all the points of one side pentagon. Now from here, see, from this A1 point, okay, so from A1 point 45.96 you can get it. You can get the line of, you can get the arcs. Okay, so from here you can get the arc there 45.96. okay, you can get the arc, and now you can have a line from this point which is perpendicular to this 90 degrees. You can maintain it. Okay, so just I am getting one line here and I am making this line 90 degrees to this. See where this line is cutting here, so this point will be A1. Okay, so this point will be A1. Then similarly you have to follow it for B also. Okay, so from this B point you can get one line. Okay, so you get one line and you make this line perpendicular to this. Using scale or protractor you can draw this line perpendicular to this directly. Here in the software we cannot make the use of protractor here, so I am using the commands here. So you can do it manually very easily. Again you can get the arc from here and you can cut 45.96. okay, so this is 45.96. again you can trim the extra lines. Okay, so like this A1, A, B you have got. Similarly you have to follow it to the C1, D1 and E1. So I will be getting the direct lines from C1, here. From C1 I am getting a line 45.96. Okay, so direct line perpendicular to this I am taking. Okay, so this point will be C1. Now from E1 also I will be doing the same thing. 45.96 I will be getting from this, and I will be making that is parallel to this. Okay, so parallel to O1. Okay, so O1 it should be parallel or perpendicular to this line. See, perpendicularity you can see there. So you can get this perpendicular, and you will be getting this E1. Similarly from here, from the D1 you can get 45.96, enter, and you can have the line parallel to this O1. Okay, so like this O1, it is on the same line. Okay, or else you can have 90 degrees to this. Okay, so here again the command constraint will be there. Okay, so different constraint it will take at one point. Okay, so like this. So now you have got all the points here, just connect them. Okay, so A1, B1, C1, D1, E1 you have a, and here A1 you have. So again I'll go to the line. Okay, so I'll make the thick line with black color. See, from A1 to B1, then C1, then sorry, we are getting A, B, C, D, E here. So this is D. Okay, so this is E and back to A. Okay, so I have named it as A1, so it will be treated as A. Okay, so you have got this. So same thing on this side. See, A1 to B1, then C1, D1, E1 and back to A1. So again you can connect A1 to A. Okay, so if I name here as A, B, C, D and E. So again if you connect all these points E1 to E, then C1 to C, then D1 to D. Okay, and this B to B1. So out of which are visible, that we have to see. Okay, so which are visible we have to make them visible, which are invisible we have to make them invisible. Say I have these two lines and this one are invisible, so make them invisible. Okay, so these three lines are invisible. So this completes the reconstruction. So this is we have done using one side box method. So this can be the simplest method what I can say. So you try with this and you try to complete the reconstruction. Thank you.